Hi and welcome to the Future of Smart Cities by CM Industrial. During this week-long webinar series, we plan to find out how cities will impact the future of the industries that we serve as a talent solutions provider. I'm today's host, Alex Mason, and this webinar is all about whether smart cities and the technological advancements that come with them can help solve one of the world's biggest issues, water scarcity. To discuss this, I'm joined with an expert panel of well-established water sector leaders to explore this topic further. But before we get better introduced, I just want to have a quick reminder that we'll be running a live Q&A later on. So if you have any questions, please feel free to pop them in the chat and we'll do our best to address them. So anyway, to get started, Nick, would you like to introduce yourself and tell us a little bit more about you and what you do at Nalco?
Certainly. So I'm Nick Bognanno. Good day, good evening, everyone. Currently, I'm a global vice president for Nalco Water, which is a division of Ecolab Corporation. I'm based in the Chicago area here in the United States of America. And I've been working with Nalco for about 31 years now, with a primary focus on industrial water treatment applications. So that's just a little bit about me. Thank you and nice to meet you.
Thanks, Nick. And Sabine, could you introduce yourself as well, please?
Yes, of course. Hello, everybody, wherever you are on the planet and beyond. My name is Sabine Stuiver. I'm the CMO and co-founder of Hydroloop. We're a Dutch company headquartered in the Netherlands. We also have offices in the US and in the Middle East. And we're a global leader in designing and creating game-changing and innovative extreme decentral water recycling systems, smaller ones for in homes and apartments, and larger ones, scalable and modular solutions for larger operations such as hotels, etc., and whatever.
Thank you very much. And Chandra.
Yeah, good morning, good afternoon, good evening, wherever you are in the world. This is Chandra Mysore. I'm a vice president and a regional lead for drinking water and reuse in Jacobs. I'm also double-hatted as a regional lead for industrial water. I'm very happy to be part of this webinar.
Thank you very much. Well, to kick us off, I wanted to start with innovation. And I suppose how we can encourage innovation, introduce new systems, new technologies to the market, how that's going to help with reuse, with saving water, and generally improving our water usage. So I think the logical place to start would be Sabine. So if you could tell us a little bit, I suppose, about what you guys are doing, and I suppose your thoughts on that, really.
Yes, thank you. Well, I think when you bring something new to the market, it has to be a real game changer and disruptive to really make an impact. That is very important when you bring anything innovative to the market, not just something that is a little bit different, but like really makes a big change. Of course, when you bring something very innovative to the market, you get a lot of resistance because most people in general like to keep doing things as they are. But of course, in our world, with, if we just look at what's happening, 2 billion more people on the planet in the coming 30 years, and we have a finite amount of water at this Earth, and we have the hydrologic cycle that has been supplying our planet for billions of years with sufficient supply, but it's already insufficient. So with more people on the planet, with climate change and pollution, and groundwater levels depleting because we are pumping it up and because we need more water, and of course everybody needs water. We have a serious, quite a lot of serious problems ahead of us. Let's call them challenges. And basically how we've approached it is that we look at it that actually every building already has a water supply, and this water supply is the lightly contaminated water. And at this moment in time, all our water, be it black or as we call it gray, so lightly like your shower and your washing machine water, all that is now collected in one single pipe, and it is wasted straight away to the sewer and taken away and treated. And basically what we're saying is if you collect it on the spot in the building itself, and treat it and reuse it again, reduce, recycle, reuse. We already briefly, before we started discussing these beautiful, this term. If you then treat it on the spot and reuse it again, you can actually you save water, save a lot of water, but you also reduce your wastewater. So this is the way, this is our innovation. And if we can really put this into we can really make sure that this is going to be in every new building, this is our mission, that within 10 years time, every new building will have its own decentral water recycling system. We can really substantially contribute towards one of the greatest challenges of mankind, drastically reducing the use of water.
Absolutely. I mean, just to add on that, I mean, the average American uses 82 gallons of water a day, with 95% of that going down the drain. So it's certainly a lot of water to be going around those systems. I mean, out of interest, Nick, is there anything that you guys have seen, or you guys maybe even do that is of a similar thing, or trying to create more internal reuse rather than just treating the water?
Yeah, I mean, what's really fantastic about where we're at today is there are a lot of digital innovations that can be leveraged to really hit on the three aspects that were just mentioned around water reduction, water reuse, and recycle. And the other advantage is these digital insights can really help us be proactive in how we're looking at water utilization and identifying opportunities to, really reduce that water stream. So there's many different options out there, but that whole data-centric piece to how we're going to deliver new solutions is really expanding, from a urban environment setting to an industrial setting, and then as Sabine mentioned, even into that a lot of residential settings for some of the solutions that they have at Hydroloop. So it's a pretty dynamic time for us right now, with a lot of new innovation from a digital perspective that can really give us a lot of insights that can lead to some very constructive activities to help minimize water demands in these watershed or water basin areas.
Absolutely fantastic. I mean, Chandra, this must be something that you've seen a big shift in as well, be it the systems, but also, I suppose, the more tech that you can use to design buildings, to design different solutions that you're doing. I mean, what's your thoughts to that?
Yeah, I think, working both on the drinking water side, reuse side, and the industrial aspects of this, I can connect these dots as well. Like, for example, we talked about how we could do internal recycling, within a building. Essentially, in Los Angeles, they are actually building new neighborhoods where they have diverters that will take, water from showers, from dishwashers, from, all these, water, which is much better, that is about 70%. And whereas the toilet water is only 30%. So you could do internal recycling within the residential system. On a larger scale, utilities are also implementing indirect potable reuse and direct potable reuse, projects. A lot of demonstration studies are going in Florida and in California and Texas. So, this is a huge topic, and the more water you conserve and the more water you recycle, the better off we are for the future, because these demands for population, as the population increases, residential, industrial demands are going to go up.
Absolutely. I mean, they say that it's 40% increase in water demand in the next 8 to 10 years. I mean, direct potable reuse, of course, is a very talked about topic, and I think it's something that it has a lot of negative connotations, especially when it comes to pitching it to the public. I know Xylem and Veolia have done a bit with making beer out of it, which always makes people a little bit happier to drink it. But it's interesting. And I remember when we talked about it, Sabine, that is actually the drinking water part is actually a really, really small part of the actual day-to-day water usage. Feel free to elaborate on that.
Well, this is the reason why many people ask us, are you creating drinking water quality again with your systems? Now we don't, and the reason is that you only drink a few liters of water per day. And for example, at the moment there are currently very, very interesting companies that are actually creating drinking water out of air. But if you look at the large users in the household, then you're looking at the showering on the one hand side and the washing machine, and on the other hand, you're looking at the toilet. So those are those are the vast users of the water. So what we've looked at is say, okay, so we take as input, we take showers, washing machines, and also cooling water from air conditioners, etc., because people don't realize how much condensation water they actually create. And this is, I mean, it looks like this. It's very clean, actually. So if we just treat that and, and basically make it clean to reuse it again for like the toilet flushing, for the washing machine, for the garden, and come on, we don't need drinking water quality for those kind of purposes. It's silly, of course, to do that. And if we already do that by using our technology, we save almost 50% on the drinking water take up, but maybe even more importantly, because this is maybe even a larger issue, it's actually the wastewater. I mean, the treatment of the wastewater is actually, the infrastructure, and I'm sure that you know more about it, is already insufficient. And so they need less water for this. So if we can create that, that is much better to have that water, being, how do you say that, more condensed.
Absolutely. I mean, are you seeing it when it comes to the commercial side, Nick? Are you especially to the large buildings, the large out hotels, things like that, the U service part of institutional Nalco? Is that something that you're seeing more and more being asked for or integrated into buildings and into solutions?
Yes, so absolutely, and particularly when it comes to gray water streams within a hotel or a commercial building, the ask is, after what we've done to minimize water usage, particularly in their industrial heating or cooling systems, how can we then find some water that can be repurposed to send back into, say, an industrial cooling tower, or to a boiler, or to be used for landscaping irrigation purposes. And so there's absolutely systems that are available in the market for a hotel or commercial building to recycle those waters for non-potable applications. And there's actually quite a few tools that can be used. We have one, we call it water flow intelligence, which can really measure from an enterprise level to a site level to an asset level in an operation, where that water is being used, how much is being used, if actions have been identified to sort of reduce consumption of water, how well is that going? Are those targets being achieved? So there's quite a bit out there nowadays to really help reuse and recycle water in industrial applications, commercial buildings, hotels, and manufacturing facilities, etc.
Fantastic. I mean, out of interest, I don't know whether anyone has any thoughts, but obviously Hydroloop, of course, is a well-publicized provider of a new solution or a new tech, in the sense that it's getting more talked about. Has anyone else seen, whether it be something at a trade show or maybe perhaps they're maybe working with at the moment, a new technology or a new solution that they really like and think has real potential to try and help solve this problem?
Are you asking us, or are you asking in the chat?
I'm asking you.
Oh, I see quite a few. I love it. There is so much innovation going on, and this is actually one of the. Of course, I'm looking in the built environment. So, of course, we have, there are so many water-saving solutions out there. And to give you an idea, this is one of the things that we want to do as a company. Within the short term, we want to provide a platform whereby you can go as a construction company, but also as a home builder, and say, okay, what kind of a home do I want? Do I want a 75-liter home? Or do I want a 50-liter home or a 15-liter home? Meaning this is the amount of liters that you will use per person per day. And then to provide the whole blueprint of how you can actually establish that. What kind of products would you then need to install in your house to actually come to that kind of water usage? So so they are like recycle showers. They are like so many different things. So I see a lot of opportunity. The only thing I think there is, I think that the solutions are already out there today. Many solutions. The only thing that we have an ambition gap. So on the one hand, we know what we have to do, but then on the other thing, on the other hand, we're not really doing them enough. I mean, if we're looking at the IPCC report from the United Nations, you know, we should be doing 4 times more on the basis of, you know, because of the climate, because of water, purely on the basis of water. So we're not doing enough already, but the solutions are out there today. So what we need to do, I believe, is that we need to spend more on the implementation of the solutions. And the focus is very much on purely innovation, innovating, which is fine, but it takes many years before an innovation becomes a product. So I think we also need to spend time and money on implementing solutions that are already out there today. Otherwise, we're never going to meet the sustainable goals and the goals that we have set ourselves.
No, absolutely. I mean, on that, Chandra, coming from, you know, a very, very well-known huge business like Jacobs, out of interest, in your sort of last few years, have you seen, or have you started implementing anything new? Have you yourself, you know, with a focus on reuse, had any new ideas that you've been implementing or technologies? What have you done, I suppose, differently when it comes to this topic?
Yeah, I think, you know, the answer is, you know, we're looking at decentralized versus centralized. So I'll cover decentralized first to add on to what Sabine was saying. Essentially, on the decentralized side, you know, what we call in our consulting paraphernalia is point of use and point of entry devices. So, you know, let's say if it's a building or a commercial, point of use could be advanced treatment just to make sure the water quality is good. Point of entry would be just below the sink. So things of that nature, you could actually see that happening even for treating. Let's say we wanted to treat gray water to a little bit higher quality, we can do that. And that I've seen that in many instances. More importantly, I'm working more on the centralized side where we see advanced treatment. So, you know, I'm actually working on a very exciting project on industrial water where we are looking at advancement in RO, conventional RO, so we can minimize the volume of concentrate. So I'm working on that. And like, you know, Nick was saying, you know, recycling water within the industrial facility so that you could, you know, instead of sending it to a sewer system, can we recycle that high quality water to meet our cooling tower needs and, you know, boiler needs and all that. So that's one area I'm working on. On the municipal side, you know, there has been a lot of, you know, indirect potable reuse and direct potable reuse projects where there is a lot of innovation that's happening in terms of UF, RO, and advanced oxidation processes, which is UV peroxide. And I won't go into too much details because I don't think we have time for that. But essentially, a lot of innovation is happening. Where I'm seeing also a lot of interest that's happening is in the area of artificial intelligence and machine learning. Can we use all these huge volumes of data and use AI machine learning techniques, you know, which is really happening, which is the cutting edge, and that is actually happening on the water reuse side as well.
Absolutely.
Yeah, it's interesting because fantastic points. And, you know, from a macro level, right, if you look at an urban environment, there's so much planning that can be done, you know, beforehand to really make sure that those water recycle or water reclamation systems are in the design and then executed. In legacy urban areas, the challenge is how do you rebuild, upgrade, and address, you know, old systems where there is significant leakage and or poor distribution that creates to a lot of water waste. So there's a lot out there. There's a lot to consider. In some of the urban areas, you know, for example, like Loudoun County, which is sort of becoming a bit of a data center hub here in the United States, Loudoun County has a water reclamation system that's currently providing about 675 million gallons of reclaimed water to those industrial customers, predominantly data centers, as they're built and developed. So they've got a nice infrastructure that's been developed and steering industrial users to that reclaimed water system that's in place. So there is a lot going on. To Sabine's point, there's a lot more that we can already do if the aspirations are there and people are really identifying what sort of industrial goals they have, or what sort of municipal goals should be in place, or what sort of residential goals in place. And then they actually have, a method to work toward those goals and monitor their progress.
And I would definitely say on that as well. I mean, it's great to hear, of course, that these projects are there, and obviously seeing successes with ones like you mentioned in Loudoun County. One thing, of course, why the US, I think, is a really interesting country area as a case study, because it has such a diversity in its ecosystem, which is very, very arid in some places, it's very, very wet in others. And we talked a little bit, Nick, I believe, about Arizona as an example, having a real problem with water scarcity and the speed at which it's growing. Do you find that this is more on people's lips, it's more being talked about by clients that already have this forced upon them? Or is it something that really we should be pushing equally among all?
Well, I would say most of our industrial customers have water and sustainability and water resiliency very much in view. And they're looking for help, they're looking for ideas on how to address these water stress challenges that we all face. One piece that I'm seeing more attention to is the fact that people are recognizing that in an area, people share a water basin, and they're becoming more aware that, they don't want to negatively impact this same water source that the city is relying on, the residents are relying on, and their partner corporations are relying on the area. So we're starting to see a little bit more and more collaboration, because that's absolutely critical to really creating, sustainable cities of the future. Is that public-private partnership is absolutely critical. And there's examples, and I'll mention, because there's a lot of expansion in this area, certain data center organizations that are partnering with local municipalities, and they're doing the investment to create the water reclamation process so that then they can reuse water for their utility applications.
Absolutely. Now, one thing I wanted to touch on, and we've touched on it briefly already, but direct potable reuse, of course, is something that's been a very hot topic. Now, it's not necessarily the be all and end all. I think there's a lot of things that can be done before we get to that point. But I know it's something you do a lot of work with, Chandra, and I suppose in your eyes, how are you seeing it going down with the public? Of course, it's it's not the easiest thing. It's maybe some people have the ick factor, as it were. Are you seeing it being talked about more and more, being more and more accepted? What's your thoughts on this becoming more widespread?
Yeah, I mean, I think, me as a technologist, we know the technology is there. We know it works. The question is how reliable it is, right? And so we have, different ways of making it more reliable. Like, for example, when we talk about direct potable reuse, obviously, the treatment processes are, generally taking secondary effluent, treating it tertiary with membranes, low pressure, high pressure, medium pressure membranes, and then advanced oxidation to make sure that, there is good, oxidation and disinfection of everything, right? So I think the technology is there. I think where the problem is coming is the public perception. How do we get over the public perception factor? And many of these direct potable reuse projects started, but did not reach their end, goal, or at least, go into construction, mainly because of this problem with the public perception. And the question is that water reliable? What happens if something breaks or something goes wrong? So that has to be overcome. So it's the mindset part of it. But right now in Florida, as we speak, I think they are going through almost like 5 demonstration studies. California, Arizona are doing the same things. So, and some regulations are also, lagging in the sense, there are, like, for example, California is still developing the draft regulations for direct potable reuse. So that also has to happen. So some of these regulations and, the public perception things have to come in tandem. But once that happens, I think we'll see more of those. But I think the biggest driver would be something like climate change, especially when when you have a real water scarcity problem, that driver is going to make these things happen faster.
Fantastic. Well, thank you for that. Now, one of the things we also want to talk about anytime we're talking about smart cities and we're talking about innovation. And I suppose for me, I wanted to ask if you could start from scratch. And some places still are, Riyadh, Saudi Arabia, as an example, is a city where you start from scratch. I know the cities in India, cities in China that have been built from pretty much ground up. If you started from scratch, how would you see it differing? And I suppose from your side, what kind of innovation and changes would you be making if you were looking at it fresh, I suppose, when it comes to designing a water system?
Well, can I just answer from the Netherlands point of view, where I'm based?
Yes.
Basically, we've basically set up the whole country that, if there is a lot of rain, it is all being flushed away through our drainage system, sewers. And now, of course, we're having to rethink all of this. So, I think everywhere in the world, it's either too much water or not enough water and dirty water. These are like the problems that we're dealing with. So I think what we should be doing is that we're having more storm water. So that means that we have a lot of water in a very short period of time. So we need to collect this water. So we need to, maintain it so it doesn't just flush away straight away to the sea, which is what we're doing right now, and retain it for later moments. I think we need to make sure that all that rainwater that we're collecting, that we're not using that inside the building, but actually keeping that outdoors, but time released, so that we are not depleting the groundwater levels even further, because that's what we've been doing. And so at the same time, and then making sure that all the water that we use, so to recycle and, reduce the usage as much as possible, which we can do, and also take away the waste stream, i.e. the black water, now has a lot of nutrients and it's not a waste anymore. We can actually, use that as a how do you say that, as a source for many other purposes. So I think that's how we should really look at it. So it's been a lot of waste basically, and now we should upcycle a lot more.
That's a fantastic point. Actually, that's something I did a podcast on last year with Frank Regala, who I know was featured in your Netflix documentary that you were in as well. He was using wastewater to turn it into biofuel, powering his car on it, which I always thought very interesting. But it's about using every part of it and reusing as much as possible, which was fantastic. Out of interest, Nick, do you get involved in brand new developments, brand new buildings, and how do you get to have an input when it comes to that to make them more sustainable and easier for water usage?
Was that to me, Alex?
Yes.
Okay, so we do get involved from the planning stages, and in an ideal situation, we're working with the engineering companies, the Jacobs of the world, and looking first in terms of how we're going to treat the influent water so it can be most efficiently used in the applications of that environment, whether it's an automotive plant, whether it's a semiconductor manufacturing plant, where it's a food and beverage manufacturing plant, and understanding the water quality that's needed for the applications within that manufacturing commercial building environment, right? So because that pre-treatment piece can help so that you can run additional cycles, as an example, in a cooling system, or additional cycles of concentration in a boiler system. And that's just a way of saying you have less water discharge to achieve the cooling that you're after, the cooling or heating that you're after. So there is a lot of work that can go in on the front end in industrial applications so that you're set up to minimize use in the first place. As well, if you're going to reuse or recycle, you need to design that in ahead of time. It's much more costly to retroactively come in after the fact and then try to build a process or a program to help recycle. And I think, you had mentioned, smart cities of the future. It's the same in that urban environment, right? The more proactive we can be in designing municipal water systems on the front end, the better that city's going to be down the road in terms of having processes to reuse or recycle water, and then having the right processes for distribution, leak detection, understanding how to use artificial intelligence, when to be proactive with your maintenance schedules. So that front end is critical.
Can I just add one more thing? And because we're also already talking about Neom City, and we're actually discussing with them as well in serious discussions. Of course, this is a long-term and a very, very fast project. But basically, if you're looking at a completely new area to build, and if it is so expensive, because it is, or to create new water, especially in a dry, arid area like the Middle East, it makes so much sense to actually, when you distribute that water, which is costing energy as well, and you're distributing to all the buildings, to actually literally give that water a second life or a third life or whatever in a building, and reuse it as much as possible before it goes to waste, basically. And that's also why we're really looking, it's our, we say, build future-proof and recycle ready. 60, 70 years ago, if you bought a washing machine, no building was made for that. So you needed to get a plumber in also to make sure that the plumbing was there, because the building wasn't ready for your washing machine. Well, now anywhere you buy or rent an apartment or a home or whatever, all that plumbing, the architect has thought about that, and the plumbing is ready for that. And this is why we're saying, it's, as you were saying, Nick, it's so much more expensive to do it in 10 years' time. And we foresee that it's not only just like nice to have, but it's going to become a necessity. And it will be stipulated by law that within the next 10 years, people will have to recycle and reduce their water usage. And so you'd better start preparing the buildings and building recycle ready and future proof right now. So that in 5 or 10 years' time, you leave it up to the consumers, or people can buy it, and the plumbing is there. It's just that's the way I think we should do it.
Fantastic. I mean, we will be moving on to the Q&A in a second. We've had lots of great questions come through. But I suppose last thoughts from you, Chandra, on this topic. But if I presume you get to use lots of greenfield projects. So what's your go-to? What's your favorite way to make sure that they are using as little as possible?
Yeah, I mean, as I mentioned earlier, like, in the US, I think, I was talking about, new neighborhoods being built with diverters, which take the gray water, which can be either internally recycled or connect by gravity to a sewer system or to a separate line system that can actually recharge the aquifer. That's one way they're doing it. And, I was thinking about the question that you were asking about, smart water and smart cities. Smart water network is one another area which India is actually putting. I'm an American of Indian origin, so there's always the Indian side of it. And in India, this is a big thing. And so India is, the non-revenue water in India is about 60%. So it's really big. So a lot of the water is lost due to leaks or it's burglarized. A lot of problems. So that smart water network helps in real time to figure out where the problems are in the network or the distribution system, as we call in the US. And that helps to conserve the water and reduce all those stuff. So AI, machine learning, all these things are coming into play in this.
Absolutely. I mean, from my side, I think it's, as you say, if you can't have one innovation without the other. I think it sounds about making sure that everyone is working together and using the data that's available and the new technological advancements together, and everything works together nicely. I think it's interesting to hear how they all sort of fit together and improve everyone else's around it. So it's great to see. Now I have some questions. We have quite a few questions, so I thought I would start asking those. So I'm sure people want to hear the answers. So I have one from Jonathan Carr. He says, is there a significant increase in power consumption and cost to buildings that use the in-house treatment plants? Or is this mitigated by additional renewable energy added to the building? i.e., is the saving in water not worth the additional cost or carbon footprint for the additional power consumed? I would presume that would be for you, Sabine.
Okay, yeah. So when we created the Hydroloop, of course, we wanted to create a system as well that uses very little energy. So in cooler climates, I mean, the system itself uses 175 kilowatt hours per year. So that's peanuts, let's call it that way. It's very little. And basically in cooler climates, there is also an energy reduction because the warm water is not being thrown away it stays in the building. So there is a remainder of the heat that is being exchanged to the environment. Also, washing machines use recycled water, which is at ambient temperatures and in wintertime. So you're not, taking colder water into the building, but you're actually using ambient temperature recycled water. So you only need to warm that up to the temperature that you want to wash with, i.e. A single unit for a 4-person family, it gives a reduction of about 600 kilowatt hours per year in energy usage, saves you that. It uses 175, so you're actually plussing a couple of hundred kilowatt hours. It was a long question. There were many questions in one question. I always dislike those because I forget what was the beginning. It also has a carbon footprint reduction. Obviously, if you look at it on all the water being distributed and pumped into your building, etc. And there is also, in Denmark, for example, an average family spends about 1,500 euros for a 4-person family per year on water and wastewater. Actually, it's 10 euros per cubic meter, 2 euros for the drinking water. It's actually 8 euros for the wastewater. That's the expense of that. So basically our units, which starts from about 3,500 euros, and I'm not here to sell it, but just to give you an idea, the return on investment there would be 6 or 7 years. Now, I had a very interesting discussion this morning, and I do think on the whole that, we have to think not only in ROI. I know running a business is important, money is important. Of course, there are some people in the world that are just, struggling just to survive. I'm not talking about those people, but for many, many of us, we mustn't just think about the return on investment, because our world needs other things. We need to do things intrinsically because it is better for the planet.
One thing I would say, I think just because it ties on very nicely from what you just said there, someone's asking about the cost side of things and maybe what can be done, whether it be financing solutions, but I think something else we didn't really get a chance to touch on would be what maybe governments can do with grants and funding for these solutions. That comes from Berry. Now, whether it be yourself or maybe Nick or Chandra can jump in on there, but your thoughts on maybe what governments can do to improve uptake of systems like Sabine's or other kind of water saving measures.
Well, I would like to say something about it, but I do also want to give you Chandra and Nick also. But just on this, Sussex, UK. So there, people are now having to build. So new construction has to be with water-saving devices. I think this is like by law now. There are grants if houses have water-saving devices. The connection to the water utility, etc. There is a rebate on that, a massive rebate. So there is a saving in that. To give an example, in the Netherlands, the municipality where our headquarters are, they are giving a subsidy to homeowners up to 2,000 euros for water-saving devices to be installed in their homes. And of course, this is really what is needed, so because we have the early adapters, they are already there. They're like the early Tesla drivers. So they are the persons that are already, have installed these systems and are doing this because they want to save water. But now we want to get the masses, and because we need to, because we need to save all this water. And so for that, yes, we do need the stimulus of grants, etc., to make that wheel kind of, spin faster and faster, like we did with solar panels. And my final remark, and then I'll shut up. Sydney Water has become our partner in Australia. Sydney Water is a water utility. It's in the top 20 of water utilities. Now, they have 5 million customers right now in Sydney, but they will have 9 million customers in the coming 20 to 30 years. And they already don't have sufficient supply. So I love their leadership because they've looked at it and they've said, okay, we need to change our business plan. And so they've embraced us, and they are now doing their first pilot with 30 homes. And if everything works well, we're looking at water as a service. So we're looking at a completely different business model whereby they may be installing the units in all the homes at their cost, but people are paying for like city water, and they may be paying another price for the gray water that they are recycling. So these are all kinds of possibilities, but we need leadership and we need forward-looking and open-minded people to look at this. Don't look at us as an enemy, but look at us as a possible, as a business partner for solutions.
Now, we've got a great question here about smart technology and perhaps how it could be better employed to improve the quality of leak detection when it comes to the mains of municipalities. Water loss and leakage is far exceeding what could be said by recycling and reuse. What's your thoughts on that, Nick? Is that something that you agree with?
Yeah, I mean, leak detection is becoming very, very critical. And so I know I mentioned earlier, you know, there are programs in place to help with that. I mean, we call ours that we have available to our customers water flow intelligence. And it's basically a digital services that uncovers everything from leaks to upsets, alarming with upsets. It provides flow measurement for all water streams within a facility. So this sort of monitoring and alarming tool and this intelligence is available so that you can optimize assets, you can recognize, identify leaks, understand the cost of that, and then go ahead and take the preventive measures necessary. And so for us, this sort of offering is a bit newer in the last year or two. I'm sure there's other ones out there, but it's so there are solutions there to help with understanding complete water flow, influent to effluent within a commercial building, a hotel, or a manufacturing operation.
Absolutely, something that we've seen a massive increase as well from a recruitment side, but we've seen, you know, we've expanded our team just to cover software and metering and smart technologies and water. You know, 3, 4, 5 years ago, we were still only ever talking about ROs or MBRs or what have you. So it's definitely increasing there. I mean, one thing I've got a question directly for Chandra here, asking you to talk a little bit more about the centralized water system that you're currently working on. Sort of what stage you're at and maybe a little bit of how that's going.
Yeah, actually, Jacobs is involved in a lot of projects. You know, I can speak in general. You know, a lot of projects are actually happening out in California. You know, where big utilities, you know, LA County Department of Sanitation and Power, Metropolitan Water District, San Diego, you know, Authority, you know, all these big utilities out in California are in the process of doing some demonstration studies. You know, indirect potable reuse is actually, you know, was there with Orange County groundwater replenishment program, where they were injecting, you know, highly treated water to aquifers. But where it is changing is also trying to recharge some lakes and reservoirs. And that is, you know, that is what is happening in California. And I think, you know, as that progresses, you know, the draft DPR, direct potable reuse regulations are in, you know, are in progress right now as we speak. So, you know, there was a commenting period just a few months ago. So a lot of those projects are happening with all these big utilities out in the West. And in Florida, you know, 5 demonstration studies have happened in DPR. In fact, one project even went further and was trying to produce beer from, you know, from recycled, highly treated wastewater. But, you know, like I said, I think the public perception is what kind of sometimes holds it back, but hopefully we'll overcome that.
Fantastic, I appreciate that. Now we've got time for a couple more, if anybody has some that they can send through. But I do have a quick one here that we can have in the meantime. Now, someone asked that whether in the US, the oil storage facilities could be a good way to be a national buffer. Do you think that their water storage facilities and their tanks could be a good way to have water available in times of drought or bad weather? Is that something you've thought of before or maybe considered? Maybe Chandra?
Using like water.
So someone's asked whether we could use oil storage facilities to store water in case of drought or bad weather.
Yeah, we call that aquifer storage and recovery ASR projects in our world. which is called ASR. So it can take two forms. Actually, it's done in a lot of states, including some clients I work in Florida as well as in Arizona and California. So it can take two forms. One is essentially taking, say a lake water or a reservoir water and injecting into the aquifer and using it as an underground storage tank. So if essentially it's like instead of an above head storage tank, it's an underground storage tank. So essentially you're storing water in the aquifer and withdrawing it as when you have a need. So that's one way to do it. The other thing that is really capturing or is growing is this indirect potable reuse, where you take secondary effluent from a municipal treatment plant, go through tertiary treatment, treat it to a very high quality, and then re-inject into the aquifer. So for example, California is way ahead of that. And California did this California's Orange County groundwater replenishment program is a flagship project. And then many utilities, including East Bay Municipal Water District, have done that. And then Singapore is doing that, so a lot of these things are happening, around the world, but that's essentially what it is. Instead of, I think an analogy for storing oil above a ground storage tank, in a ground storage tank above the ground is the equivalent of this. Yeah.
Jonathan's added a little bit extra to actually asking whether it'd be a good idea to having regional tank storage network for water. So perhaps actually having that set up so it's ready to go when needed.
Yeah, I think that has been talked about, and it's just the volume of water that you need is a big thing, and then the area to do that. Yeah, but that's something that has been talked about here in the US, but it hasn't happened.
Yeah,
okay,
and you mentioned some of these aquifer replenishment programs. So for those interested, you can just search on the internet for Orange County or Orange County Reclamation. So they currently have a groundwater replenishment system that provides 130 million or so gallons a day. So that's the type of volume you're seeing in some of these larger municipalities where they're doing this. In addition to the groundwater replenishment, they also have the aquifer replenishment programs they're doing. So we're talking millions of gallons a day with some of these systems that Chandra is referring to, but you can just do a search on the internet for Orange County, and there's a lot of really interesting information about what they're doing within that county from a water perspective.
But I think it touches, Nick, on the fact that the vastness of how much water, people, the normal user has no idea how much water they use per day, and what kind of an aquifer you need to actually store that kind of water, because it's a tremendous amount.
Yeah. And I think, I'm thinking the question arises, and this has been interesting because, it has been talked about in a lot of conferences, like, for example, gasoline companies here in the US, store and distribute gasoline through a wide distribution network all around the country. Why can't we do that for water, especially in areas where there is a drought? That question has come up. It's just the infrastructure, the cost of involvement in doing that. And when you're crossing state boundaries, you have to get a lot of states to agree on that. So that hasn't happened in the US, but that's a good question.
And I've got time for a quick last one. Now, I do apologize to Pierre that I missed his question, so I want to make sure that I get that asked. So he's asking what the maximum percentage range of water saving in the case of domestic use and the innovative design and products available in the market. He wants to get an idea of how much it's saving the user. Probably for you, Sabine, I would imagine.
Yes. Well, I don't. Oh, sorry. I hear a strange sound at the moment. I hope everything is okay. Okay. With our system, with all this, it also depends on how you use it. So with our systems, a family can save, a normal, with normal usage in Europe, you can save 70,000 liters per year with a 4-person family. But it depends on how you use it. So for example, if everybody has a shower for half an hour, that's going to be too much at the same time for the system to treat. So you will not save as much. So it depends a little bit, you know, on the how you as a user use it, basically. So with our system, it's up to 45% of water saving and wastewater saving as well.
Fantastic, thank you, Sabine. So from now, I think it would be a good place to end. To be honest with you, we've managed to cover a lot of different topics and had a lot of great questions answered. But yeah, it's something that I want to thank everyone for coming to the webinar today. So apologies if you won't be able to address your question. I'm sure if you're able to DM me or maybe our panel directly, they'll happily respond with an answer for you. We will have recorded the event today as well, so we will send you an email with that as well. And we'll be creating a downloadable PDF featuring today's main takeaways, but as an insight from our previous Future Smart Cities webinars we've been holding all week. Monday's event was on how to build a smart water network with Lyle King, so he'll be able to tell you some more as well. Finally, if you have an upcoming hiring project and would like to find out more about CM Industrial and how we're striving to change the way the world sees recruitment, then please get in touch. You can do so by sending me a DM or going to searchingindustrial.com. Anyway, that's it from me. Thank you again. Thank you to my panel and thank you to everyone attending today. I hope you have a fantastic day.
Thanks. Bye.
Thank you all.
Thank you all very much. Be wise, use water twice. Just wanted to say it again.
Good logo.